Hey guys, Blake Ritchie back here with Honey Creek Design Build, and this month's video we're going to walk you through some post-frame construction and specifically some EPS Buildings, a company that we're a dealer for, and why we use them and their preferred method of post-frame construction. So this is a 32 by 64 post-frame building. So if you don't know, just a basic rundown on a post frame is we have these 8x8 or 6x8 or 6x6 posts, every 8 foot on center, and so that's why we call it a post frame, because we're framing with posts. And then you put these 2x6 girts on the side of the post up to hold the steel on the building. Very typical in shops and ag style construction. This one is specifically ag, is going to be a cattle shed. So I'll show you coming up a different method of how we do our footings, but this one, since it's an ag style, we just have posts in the ground and then we backfilled that with rock to allow for some drainage around that post so that wood isn't in direct contact with mud its entire life and to try and evacuate some of that moisture. But anyways, this is an EPS building. That's who we buy our building packages from. EPS is Energy Panel Structures. They're based here in Grettinger, Iowa. So we're a dealer for them, and we really like their products, mainly because it's an engineered plan. Some are pre-engineered, or you can get them stamped if you need a specific thing figured out. But there's nothing here that's guesswork. We get a full set of prints that we build from. Everything's called out, exactly what penny nail, how many nails, in what girt, on what wall, go where. So it gives me as a builder a good sense of reassurance or insurance per se, that knowing that this building's engineered to withstand a certain amount of wind load and stuff like that, especially after like the storms we've had here the past couple years in Iowa. So that's why we like going this route. It's somebody else's print, somebody else's plan that we know is gonna stand up, and it's engineered according to the zone that's being built in. So you can kind of see here on this particular building, our sidewall girts are a different layout than our end wall girts. And that again just speaks to the engineering and the different shear loads that this building requires on certain walls. The other thing we have here, the bottom row is treated, the rest is non-treated lumber. The post base is treated, then it will transition on certain posts to non-treated lumber again. This is a monoslope roof. So we have trusses every 8 foot on center that are through bolted to our post. And then we have 2x4 roof purlins that we call them on edge on top of the truss every 2 foot on center. And then on this roof too, there's a lot of wood that goes in these roof truss systems. So there's 5 rat runs that we call it, or wind ties, that stretch the entire length of the building. There's some T diagonal bracing at each end. There's some X bracing in the middle. And there's also some web bracing that's called out that they don't put on factory that we have to put on site because they can't ship them if they do that T bracing, so we install that. So everything's called out, it's very specific. So we like that, since we're following a set of plans that are actually engineered, and so there's not guesswork going into this. Another thing this building has, it's got this opening in the middle. Wanted this opening big enough to get equipment in and out of, so we didn't want to fit between 8 foot that might limit you on like a tractor coming in here to scoop manure out or something. So we did 1 post instead of 2, and so then we headered it again. Header size is all actually engineered specific. There's Simpson brackets and ties and all that stuff that's specifically called out for this building itself. So another thing this building features is we have 7 Plyco brand wall vents, they're called. This is the biggest insulated wall vent that this company sells. We said this is gonna be a cattle shed, so this will allow for some ventilation. They can prop these open and ventilate, and then they can shut them in the winter. If he opts to insulate this building later on down the road, he'll already have an insulated, basically window or vent system. The other thing we did is we put Tyvek behind the steel. This customer talked about possibly spray foaming it. So we don't want that spray foam tight to the steel, rusting it out, making it hard for replacement ever, if that was ever an issue. So we put the Tyvek on as a barrier to allow a spray foam installation later on down the road. So this is a 8x8 sliding door. It's made by MWI Components. that is still a part of our EPS Buildings package, but it's a full metal door with this aluminum frame and these aluminum girts. So this door will never rot out. It's also very light, so it's not heavy to push and pull open. It comes with these built-in stops so it can't roll off the rollers either way. There's a bottom track and a top track. Then these are what's called snuggers that keep the door tight in the event of a windstorm. It can't help it from blowing off. So that's a nice door. We've seen a lot from the derecho, for instance, of doors that blow off, or partially because they were rotted out. So that should never be an issue here, since this is a full metal door. Again, there's no rot that can take place here. So another thing that this building features is this Dutch door. It's a 4-foot wide door. Again, made by MWI components, but supplied through EPS Buildings. So the top opens separate from the bottom. This is a full steel construction door. Again, very solid, very rigid, no sagging, steel frame on steel hinges, and also at that, a very nice aesthetic looking door that looks very pleasing. We pay high attention to our trims and the details, and so on our caps and corners, what we do is a fold return on all that, so nothing's exposed, so bugs and stuff can't get up in there. Our base trim is mitered. Everything's mitered that can be mitered, the J around the windows and stuff like that. So we just try and take the time to fold and do those little extra details on the trims. To us, that really just kind of sets off the building. So that's a quick walkthrough of this EPS building we showed you behind here. We're going to take you to another project where we have the footings in the ground and show you a little different method of footing construction. So here we've drilled a funnel tube, we call it, or a pier footing. So we've drilled with a skid loader a 4-foot deep pier, filled that with concrete, and then we came through and wet set these metal brackets in the concrete when it was wet. So we set up a string line on these grade boards, and then we set it perfect to that string line. And so now the benefit for us is we don't have wood in the ground, number one. We have concrete so it won't rot out. And then number two, we'll actually build our wall on the ground and then stand it up like a conventional stick frame house would be. So we can set all of our posts in here, lay them all out on the ground, gird it, square it right on the ground, then we'll stand it up in sections. And so we found that the faster method of construction for us overall, of putting the footings in and building the walls, and then also a better system at that, because now you have concrete in the ground versus wood in the ground. So this is the actual wet set bracket that we use. This one's made by Sturdy Wall, and it's made for a 6x6 post. So it's 5.5-inch side flange. And then we got 2 through bolts that we put through the wall, and then a couple other Simpson type structural screws. But you can see it's got 4 pieces of rebar. And so when we pour this, it's wet, we'll come through, and then we'll set this down into the concrete when it's wet to get it perfectly in place. And this holds it in place, keeps everything from moving. Once this is solid, there's no moving this, there's no pulling this out. To me, it's stronger than wood. I don't have the actual data in front of me, but if you were to pull a post out like this, connect it to this, and then one just wood in the ground, I would put my money on this every day. So we're here on site, another EPS project that we finished a year or two ago. And this is a little different. It's not post frame construction. This is a SIP construction, which is SIP stands for structural insulated panels. So what we showed you earlier was post and frame construction. This is a foam core wall with plywood skins, but from the exterior, you wouldn't even know it. It looks the exact same with steel cladding everywhere. So this is an American Legion Hall, but again, another EPS building that was fully engineered, a full set of prints. Everything is designed for the building specifically itself. So just another glimpse of EPS Buildings and the different types of construction they offer and what it can do for you and how it looks from the outside in comparison to a post frame building.